In this video, we'll discuss solving trigonometric equations, that is, equations that involve trigonometric functions. To understand this, let's just go straight in and do some examples. Our first example you see here. Solve sine of theta equals 1/2 for theta between 0 and 2 pi. That is, including 0 but not 2 pi. 0 is less than or equal to theta, is strictly less than 2 pi. The goal here is to find the values of theta that make this true. An invaluable tool in a problem like this is the unit circle. Let's draw a small unit circle. The sine value is the y-coordinate on the unit circle. So here we want to find all of the points on the unit circle that have y-coordinate 1/2. So that's where y is 1/2. So this is the point where the coordinates are square root of 3 over 2, comma 1/2. This belongs to the angle pi over 6. On the other side, in quadrant 2, we have coordinates minus square root of 3 over 2, comma 1/2. The angle here is 5 pi over 6. We know it's 5 pi over 6 because the reference angle is pi over 6. 5 pi over 6 plus 1 pi over 6 is 6 pi over 6, which is pi. So what we found is that there are two values between 0 and 2 pi such that sine of theta gives you 1/2. Notice that the unit circle includes all of the angles between 0 and 2 pi. That's one revolution. So what do we have here? We have that the solutions are theta equals pi over 6 and 5 pi over 6. Those are our two solutions. Here's another related example. For example 2, it says, find all real numbers theta for which sine of theta equals 1/2. So now we're not just restricting our attention to angles between 0 and 2 pi, we're allowing theta to be any real number. However, the procedure is still the same. We draw our unit circle, and we figure out what coordinates on the unit circle have sine of theta equals 1/2. And it's the same as before. So that's where the y-coordinate is 1/2. So we know then that we have the angle pi over 6 and the angle 5 pi over 6. This gives us the two answers between 0 and 2 pi. So if we write down theta equals pi over 6 and theta equals 5 pi over 6, that's two of the solutions. But there are many, many more. In fact, any coterminal angle will also be a solution. So pi over 6 is a solution. But if we add 2 pi to this, that is, if we add a complete rotation, then we get another solution. So pi over 6 is a solution, pi over 6 plus 2 pi is a solution, and then you can go around again and again and again. So we'll have pi over 6 plus 4 pi is a solution, and so on. Similarly, we have that 5 pi over 6 is a solution, but again, any coterminal angle will also be a solution. So we'll also have 5 pi over 6 plus 2 pi, 5 pi over 6 plus another 2 pi, which gives us 4 pi, and so on. And not only do we add positive rotations, but we can also add negative rotations. Any coterminal angle, whether it be obtained through a positive rotation or a negative clockwise rotation. So we can also do pi over 6 minus 2 pi, pi over 6 minus 4 pi, 5 pi over 6 minus 2 pi, 5 pi over 6 minus 4 pi, and so on. There are in fact infinitely many solutions, but how do we write them all down so that way we don't have to have an endless list like this? The way that we do it is we introduce a parameter. Usually we use k. K is any integer. So the idea is that we would write that theta can be equal to pi over 6 plus 2k times pi, where k is an integer. Well, if k is any integer, then 2 times k is any even integer. So pi over 6 is our first solution, and then we add an even number times pi. 2 pi, 4 pi, 6 pi, 8 pi, so on. Any even number times pi. If k is any integer, then 2k is an even number, and we can get all even numbers that way, even the negative ones, because k could be a negative integer. So we have pi over 6 plus 2k pi, where k is any integer. That gives us all of the first solutions, all of the solutions that are coterminal with pi over 6. We can do the same thing for 5 pi over 6. So theta is equal to 5 pi over 6 plus 2 times k times pi, where again k is any integer. Let's do another example. For example 3, we're asked to solve 2 times cosine theta quantity squared plus cosine theta equals 0 for 0 less than or equal to theta less than or strictly less than 2 pi. So our equation is 2 times cosine of theta quantity squared plus cosine of theta equals 0. So the first thing to do is to factor out a cosine theta. Don't divide by cosine theta because cosine theta might be 0. So if you factor out a cosine theta, you'll have 2 times cosine of theta plus 1 is equal to 0. So in order for this product to be equal to 0, one of the factors must be 0. So either cosine of theta is equal to 0, or 2 times cosine of theta plus 1 is 0. If 2 times cosine theta plus 1 is 0, then cosine of theta must be equal to minus 1/2. So what we have here are two equations that we need to solve for theta. Either cosine of theta is equal to 0, or cosine of theta is equal to negative 1/2. And again, in order to solve these, we turn to our good friend, the unit circle. So here's the circle, and let's draw x-axis and y-axis. Well, we can try a little bit harder with that y-axis. Well, that's close enough. Well, maybe that's a little bit better. So anyway, cosine is the x-coordinate. So if the x-coordinate is 0, then we're either up at the very top of the circle or at the very bottom of the circle. So that's where we have coordinates 0, 1 and 0, minus 1. So at the top of the circle, that angle is pi over 2. At the bottom of the circle, the angle is 3 pi over 2. So that tells us that either theta is equal to pi over 2 or 3 pi over 2. Any angle which is coterminal with either of these will also give you 0, but we're only looking inside the set where theta is between 0 and 2 pi. That's within one complete rotation, one complete counterclockwise rotation. So we don't have to worry about any angles other than pi over 2 and 3 pi over 2, at least not for this first equation. But now we have this other equation. Cosine of theta equals minus 1/2. Again, we're looking at the x-coordinate. So if the x-coordinate is minus 1/2, that's over here. So that gives us this angle and this angle. So the first of these angles is 2 pi over 3. And the second angle, where we go all the way around here, that angle is 4 pi over 3. We know that because this is 1 pi over 3, 2 pi over 3, 3 pi over 3 is pi, and then 4 pi over 3. So that gives us two more angles. So here we have theta is equal to 2 pi over 3 or 4 pi over 3. So if you put all these together, those are the solutions for this problem. Theta equals 2 pi, theta equals pi over 2 or 3 pi over 2, or theta equals 2 pi over 3 or 4 pi over 3. Let's do another example. Find all real numbers theta for which 2 cosine theta squared minus sine of theta is equal to 1. Okay, so 2 times cosine theta squared minus sine of theta is equal to 1. Let's just rewrite this. 2 times cosine of theta quantity squared minus sine of theta is equal to 1. Now the main problem here is that we have a sine and also a cosine. So what we want to do is convert them either all to sines or all to cosines. The easiest way to convert between sine and cosine is to use the Pythagorean theorem. Here's a cosine theta squared, so let's just convert that into a sine theta squared using the Pythagorean theorem. So this is going to be 2 times 1 minus sine of theta quantity squared minus sine of theta equals 1. Okay, let's distribute that 2 now. So this will be 2 times sine of theta quantity squared minus sine of theta equals 1. Now our goal here is to solve, or our first goal is to solve for sine of theta. And once we solve for sine of theta, then the next step is to figure out what theta actually is. So one thing that we can do to make this a little bit easier is we can use what we call a substitution. I can let some other letter represent sine of theta. So let's just go u. Let u be equal to sine of theta. So every place I see a sine of theta, I'm going to replace it with a u. So we're going to have 2 minus 2 times u squared minus u is equal to 1. The reason that I do that is now I'm looking at this and I say, oh, that's a quadratic equation in terms of u. So I can solve this for u. If I solve that for u, but u is equal to sine of theta, then I know what sine of theta is. So this is going to be, let's write this as, we can subtract this 1 from both sides. So we'll subtract 1 from here and 1 from here. Then we'll have 1 minus 2u squared minus u is equal to 0. Let's just rewrite all of this. So this is minus 2u squared minus u plus 1 equals 0. Let's run a minus sign through everything. So it's 2u squared plus u minus 1 equals 0. This will just make it a little bit easier to factor. So this is going to give us, let's write down our parentheses. So the only way to get 2u squared is 2u times u. And the only way to get 1 is 1 times 1. It's a negative 1, so these have to be opposite sign, but the middle term is a positive u. So that means the larger term has to have the positive sign. So we'll put a positive here and a minus here. So now we have 2u times u is 2u squared. Then 2u times 1 is 2u minus 1 times u. That gives us the positive u. And then negative 1 times 1 is negative 1. So what we have here is that 2u minus 1 is equal to 0, or u plus 1 is equal to 0. So this equation tells us that u is equal to 1/2, and this equation tells us that u is equal to minus 1. And this is when we remember, oh yeah, u is equal to sine of theta. So in that case, we know that sine of theta is equal to 1/2, or sine of theta is equal to -1. So here we have two equations that we can solve to give us our values of theta. Actually, let's highlight them like we did before. So we need to find all values of theta for which these equations are true. And once again, I want to refer to the unit circle. So let's draw a little circle, like so. Okay, so sine is the y-coordinate. So we want to look for the points on the circle where the y-coordinate is -1. Well, that's only down here, where x is 0 and y is -1. And that angle is 3 pi over 2. So the solutions that we get from sine of theta equals -1 are 3 pi over 2. Well, that's just one, but we're looking for all real numbers. So for this one right here, we get that theta is equal to 3 pi over 2. However, we can add any even number times pi, where k is some integer here. So 2k times pi, where k is any integer. Since k is any integer, we can get any even number. And an even number represents a complete rotation. So to get all of the coterminal angles, or all of the angles that are coterminal with 3 pi over 2, we add in 2k pi, where k is any integer. What about sine of theta equals 1/2? Again, we're looking at the y-coordinate. So we want the y-coordinate to be 1/2. So that gives us something like this. So this angle is pi over 6, and this angle is 5 pi over 6. So what that tells us is that our angles are pi over 6 and 5 pi over 6, and of course 3 pi over 2. But again, we have to add in all of the coterminal angles. Where again, k is any integer. And that gives us all of our solutions. Let's do another example. Cotangent of theta equals 1/5 cosine of theta. We want to solve this equation for all theta between 0 and 2 pi, including 0. So the equation that we're looking at is cotangent of theta equals 1/5 times cosine of theta. Now, in order to solve this, what we're going to do first is write cotangent in terms of sine and cosine. So cotangent is cosine of theta divided by sine of theta. And this is equal to 1/5 times cosine of theta. Okay, so what you don't want to do is divide everything by cosine theta, because cosine of theta could be 0. So instead what we're going to do is we're just going to subtract 1/5 cosine theta to the other side. So we'll have cosine theta over sine of theta minus 1/5 cosine of theta is equal to 0. So instead of dividing by cosine theta, what you want to do is factor it out. So we have cosine of theta times 1/sine of theta minus 1/5 is equal to 0. So in other words, we have a product which is equal to 0. So the only way a product can equal 0 is if one of the factors is equal to 0. So either cosine of theta is equal to 0, Or the other possibility is that 1 over sine of theta minus 1 over 5 is equal to 0. Now the only way that this last equation can happen is if sine of theta itself is equal to 5. Now that is not possible. Not possible. Remember that sine is always between minus 1 and 1. So it's not possible for sine of theta to equal 5. So the only way you can have a solution to this equation is if cosine of theta is equal to 0. What values of theta give you cosine theta equal to 0? Well, once again, let's draw a unit circle. If you take nothing away from this lecture at all, except for one thing, let it be that you should draw the unit circle. Make the unit circle your friend. What we're trying to do is find all of the values of theta where cosine of theta is equal to 0, at least all of the theta between 0 and 2 pi. So that's one complete rotation around the unit circle. Cosine is the x-coordinate. So if the x-coordinate is 0, we're either at the top of the circle or at the base of the circle. The top of the circle is 0, 1, and the base of the circle is 0, minus 1. The top of the circle, that angle is pi over 2, and the bottom is 3 pi over 2. So that gives us our two angles. So theta equals pi over 2 and 3 pi over 2. And that's enough, because we're only inside this interval between 0 and 2 pi. If we were asked to find all of the real values of theta for which this equation holds true, then we'd have to do that plus 2k times pi thing, but we don't have to do that here. Okay, so example 6 asks us to solve the equation the square root of 3 times tangent theta minus 2 times sine of theta times tangent theta is equal to 0. And again, we're just sticking to the interval between 0 and 2 pi. So that's one revolution around the unit circle. Okay, so the first thing we're going to do here is we're going to factor out a tangent theta from both of these terms. So we'll have tangent of theta times the square root of 3 minus 2 times sine of theta, and this quantity is this product is going to equal 0. Let me just fix my theta. So we have here that tangent of theta times the quantity square root of 3 minus 2 sine of theta is equal to 0. So we have a product which is equal to 0. That means one of the factors has to be equal to 0. So either tangent of theta is equal to 0, or the square root of 3 minus 2 times sine of theta is equal to 0. Well, this equation is the same as saying that sine of theta is equal to the square root of 3 over 2. Okay, so we want to figure out where tangent of theta is 0 or sine of theta is the square root of 3 over 2. Well, tangent of theta is equal to 0 precisely when sine of theta is equal to 0, because tangent is sine over cosine. So the only way that tangent can be 0 is if sine is 0. Okay, so we want to find all of the angles theta such that sine of theta is equal to 0 or sine of theta is equal to the square root of 2 over 2, or excuse me, the square root of 3 over 2. So once again, we draw a unit circle. Again, make the unit circle your friend. Sine of theta equals 0. Sine is the y-coordinate. So the only way the y-coordinate is 0 is if you're as far to the right as you can be or as far to the left as you can be. So if you're as far to the right as you can be, that's 0. That's the angle is 0. So let's write that just so it's clear. That's theta equals 0 there. Now if you are far to the left as possible, that's half of a rotation. So that's pi radians, or 180 degrees. Okay. It also could be 2 pi, but that's why we don't include 2 pi, because 0 is coterminal with 2 pi, so you only need one or the other. Here we're not asking for all real numbers where this is true. We're only asking for the angles theta between 0 and 2 pi, including 0, but not including 2 pi, so we don't have to worry about that. So this equation, sine of theta equals 0, sine of theta equals 0, this gives us two solutions. Theta equals 0 and theta equals pi. Okay, so the next one is sine of theta equals the square root of 3 over 2. So again, we're looking at the y-coordinate here. So square root of 3 over 2 is something like that. It's when the x-coordinate is 1/2. So you have 1/2 square root of 3 over 2, and you also have minus 1/2 square root of 3 over 2. So the one in the first quadrant, that's the angle pi over 3. The one in the second quadrant, that's the angle 2 pi over 3. So that gives you the other two angles. Theta equals pi over 3 and 2 pi over 3. And that's all we're looking for. If it had asked us for all theta for which this equation is true, we would have had to do that thing with 2 pi k. Well, let's actually write that down. So note, the solutions for this equation without the restriction that theta is between 0 and 2 pi, so the solutions for this equation for any real number theta are, so in this case it would be theta is equal to 0 plus 2 pi k, so that's just, or 2k pi, so that's really just 2k pi, and then pi plus 2k pi, and then pi over 3 plus 2k pi, and then 2 pi over 3 plus 2k pi. Now, something that's interesting about these two solutions, notice what they really are. You're looking at 0, and then if you add 2k pi to that, that's going completely around the circle. So you're getting all of the even multiples of pi. What about this one right here? It's pi, but if you go around again, it's going to give you 3 pi. So this one, let me just change the color here. So this one here, this is 0 and 2 pi and 4 pi and so on. This one, on the other hand, this one is pi and 3 pi and 5 pi and so on. And also we can have plus or minus this. So it could be plus or minus 2 pi, plus or minus 4 pi, and so on. But notice it's actually just all of the integer multiples of pi. So collectively, these solutions can just be written as k times pi, where k is any integer. So this is where k is any integer. For all three of these. Now for this particular problem, we were only asked to solve this equation for theta in the range 0 to 2 pi. So we only had these four solutions. So we had those two solutions and these two solutions. However, if we wanted to find all solutions, you would have all of these. If you were looking for any real number that was a solution to this equation, you'd have k pi, pi over 3 plus 2k pi, and 2 pi over 3 plus 2k pi, where k is any integer. Let's do another example. Find all real numbers theta for which 4 times sine of 5 theta minus 2 is equal to 0. Okay, so what we're looking for is we're looking for all theta such that 4 times sine of 5 theta is equal to 2 if we just add this 2 to both sides. And then we divide both sides by 4. So we're looking at sine of 5 theta equals 1/2. So now we're looking for not theta such that sine of theta is 1/2. We're looking for the theta so that sine of 5 theta is 1/2. Well, what are the angles that give us 1/2? So once again, let's look at the unit circle. So we're looking for all of the places on the unit circle where the y-coordinate is 1/2. So again, that's halfway up here. So that gives us, so this angle is pi over 6, and this angle is 5 pi over 6. So what we know is that sine of 5 pi over 6 gives us 1/2, and sine of pi over 6 gives us 1/2. So what does that tell us? That tells us that our angle is 5 pi over 6 or pi over 6, but our angle is 5 theta. It's not theta, it's 5 theta. So that means that 5 theta must either be 5 pi over 6 or pi over 6. So 5 theta equals 5 pi over 6. Well, plus 2k pi. Or 5 theta equals pi over 6 plus 2k pi. So we know that sine of pi over 6 is 1/2, and we're looking for all of the 5 thetas such that sine of 5 theta gives us 1/2. So that means 5 theta must be pi over 6. Well, the other option is 5 pi over 6. Now, our objective isn't to solve for 5 theta. We want to find all real numbers theta for which this is true. So all we have to do now is divide everything by 5. So the first one here, we divide everything by 5, and we have that theta is equal to pi over 6 plus 2 pi, or 2k pi, divided by 5. And the second one is theta over pi. Theta equals pi over 5 times 6 is 30, plus 2k pi over 5. And that's our answer, where again k is any integer. First, we look at sine of 5 theta equals 1/2. So 5 theta is some angle such that sine of that angle gives us 1/2. But the possible angles for that are pi over 6 and 5 pi over 6. So that means that this angle must be either pi over 6 or 5 pi over 6. Now I add in these 2k pi because we're looking for all real numbers. So the coterminal angles also work. So one angle that gives us sine of whatever is 1/2 is pi over 6, right? That's one of the angles for which sine of that angle gives us 1/2. But all of the angles coterminal with it also have that property. So that's why we add on the 2k pi. This is all even numbers times pi. So we're looking here at all complete revolutions, or all complete rotations. Now these are the angles such that sine of an angle gives you 1/2. These ones or these ones. But the angle is 5 theta. So 5 theta equals 5 pi over 6 plus 2k pi. Or 5 theta equals pi over 6 plus 2k pi. But we're trying to find all real numbers theta, so that means you have to solve for theta. So you just divide everything by 5. If you divide 5 theta by 5, you get theta. If you divide 5 pi over 6 by 5, you get pi over 6. But you also have to divide 2k pi by 5. So we're dividing both sides of this equation by 5. So that means you have to divide everything by 5. And that includes the 2k pi. So you divide the 2k pi by 5, and that's where this 2k pi over 5 comes from. We also have to divide the second equation by 5. So you divide 5 theta by 5, and that gives you this theta. And then you have to divide everything on the other side by 5 as well. So pi over 6 divided by 5, that means you have a 6 in the denominator and a 5 in the denominator, so that's why you have 30. And then you have 2k pi divided by 5. So that's where these solutions come from, where again k is any integer. Let's do one more example. Find all real numbers theta for which tangent of 4 theta quantity squared equals 3. We start with the equation tangent of 4 theta quantity squared equals 3. And then we compute the square root of both sides. So if tangent of 4 theta squared is 3, that means that tangent of 4 theta is plus or minus the square root of 3. So we want to figure out what angles give us a tangent of plus minus square root of 3. So let's write tangent in terms of sine over cosine. So sine of 4 theta divided by cosine of 4 theta is equal to plus or minus the square root of 3. Now the way that tangent can be square root of 3 is if it's the square root of 3 over 2 divided by 1/2. That's how you can get a tangent equal to the square root of 3. In that case, you need to have cosine equal to 1/2 and sine equal to the square root of 3 over 2. Now we have a plus or minus here. That means that either sine is allowable on the square root of 3 over 2 or on the 1/2. Let's draw a unit circle, like so. Now what angles give us this situation? Well, what we want is we want sine of some angle, let's call it alpha, to be equal to square root of 3 over 2. And we want cosine of alpha to be equal to 1/2. Now maybe I should have written these in the opposite order because cosine is the x-coordinate. So let's do it like that. So we want the x-coordinate to be 1/2 and the y-coordinate to be square root of 3 over 2. So if the x-coordinate is 1/2, then we can either have a positive square root of 3 over 2. So this will be 1/2 square root of 3 over 2. Or we could have a negative, because this is plus or minus. So it could be a negative, in which case we have 1/2 negative square root of 3 over 2. So this could be plus or minus, but this one could also be plus or minus. So we could have a minus 1/2 here. If we have a minus 1/2 as our x-coordinate, we can have minus 1/2 and positive square root of 3 over 2 for our y-coordinate, or they could both be negative. These are our possibilities. Well, what could our angle alpha be in this case? So alpha could be this angle, or this angle, or this angle, or this angle. So I didn't quite draw that as a straight line like I should. It should be more like that. And like that. Okay, so this angle is pi over 3. And the angle in the second quadrant is 2 pi over 3. Now 3 pi over 3 is pi, so that's over here, that's 180 degrees. Then this one is 4 pi over 3. And then this one is 5 pi over 3. So in other words, our angle alpha is either pi over 3 or 2 pi over 3 or 4 pi over 3, or 5 pi over 3? Well, these are the angles inside the interval from 0 to 2 pi. Now, in fact, we want to allow for all real numbers, so we can use all of the coterminal angles. So what we could do is we could say that alpha is equal to pi over 3 plus 2k pi, and for all the other ones too. 4 pi over 3 plus 2k pi, and then finally 5 pi over 3 plus 2k pi. However, we can simplify this a little bit, because notice that pi over 3 and 4 pi over 3 are pi apart from each other. So a complete circle, so let's start at pi over 3, and we could go around the circle in a complete rotation, and that would give us an angle that works, another angle that works. But we could also just go a half rotation, which is rotation by pi, and that would take us from one angle that works to another angle that works. Similarly, 2 pi over 3 plus pi is 5 pi over 3. So if we're at 2 pi over 3, we can do either a full rotation to get to a coterminal angle, or we could do a half rotation to get to a different angle that also works. So what that means is that if we start to write down our viable solutions for alpha, then we could say that alpha starts at pi over 3, and then we could add 2 pi, but we could also just add 1 pi. So you can add pi, or 2 pi, or 3 pi, or 4 pi. So in fact, what we want to say is k times pi. That will take the pi over 3 and also the 4 pi over 3. Now we also have 2 pi over 3, and to that you can add 2k pi, but you could also just add 1 pi, and that will bring you over here. So it'll just be k times pi. So what that tells us is that we have a lot of angles at work. We can have pi over 3 times k pi, where k is any integer, or we could have 2 pi over 3 plus k pi, where again k is any integer. Now these are our angles theta that work, but in this particular case, this angle alpha is 4 theta. So alpha is 4 theta. So that means 4 theta is equal to pi over 3 plus k pi, or 4 theta is equal to 2 pi over 3 plus k pi. Solve for theta, in other words, divide by 4. So here we have theta equals pi over 12 plus k pi over 4. Or here, if you divide by 4, you'll have theta equals 2 pi over 12 plus k pi over 4. Now that simplifies. That's pi over 6. So your solutions end up being theta equals pi over 12 plus k pi over 4, and theta equals pi over 6 plus k pi over 4, where again k is any integer. And these are our solutions. In this case, we don't do 2k pi because we have solutions, we have angles here. It's not just the coterminal angles, but it's also the angles on the opposite side, which are just pi units away. So we can combine these two cases. So we can combine these two cases to this. So let me just change the color. So we can combine these two cases into one. And we can combine the other two cases into one as well. So those go here. So in other words, we have 4 cases, but we're able to combine them into 2. Once you have the angle alpha, then you remember, oh yeah, alpha is equal to 4 theta in this case. So in order to solve for theta, you just divide everything by 4. And that's your answer.